Hey everybody, it's Lucas Wilkerson, the Math Coach here, and today I'm going to be working through a video on 2.5 and 2.8, or 2.5 to 2.8. So for question 1, begin by graphing f of x equals to x squared, then use the transformation of the graph given the function. So looking at number 1, we see inside the parentheses, when it adds, we're going to go left. So this is left 2. And if it was subtraction in the parentheses, then it'd go right. However, when it's outside the parentheses, when it's a negative, we go down. When it's a positive, we go up. So looking at these graphs, the solid line is the original function, the x squared, and the dotted line is the transformation. So if you look at all these, you're going to realize number A, which isn't actually a number, I mean letter A, is actually left 2, down 3. And you just do that by observing it. Now for number 4, it says begin by graphing f of x cubed, then use the transformations given the function. So looking at this one, there's a little more going on here. For instance, it's all being multiplied by a negative. And since it's all being multiplied by a negative, it's going to reflect over the x-axis. So reflect x-axis. Inside is being subtracted by 2. So we'll go right 2. And then the outside down 2. So looking at these graphs, it needs to be reflected over the x-axis, right 2 and down 2. And if you look at all these, you're going to see that it is A. Moving on to section 2.6, we need to find the domain of the function. So let's see, how do we want to do that? First, we need to set denominator not equal to 0. That's because if the denominator is 0, this will be undefined. And then we'll just factor. So we're just going to look at the denominator for this. Since we're just looking for the domain, we can take an x out of this. Then x squared minus 81. By looking at it, we should be able to observe this. And then we can see x cannot be 0, -9, or 9, because then it would equal 0. So if you plug 0 in, it would equal 0 and we can't have 0. If you plug -9 in, it'd be 0 and we can't have 0. If you plug +9 in, it would be 0 and we can't have 0. And then what this would look like for interval notation, this is going to be the more confusing part. It always starts at the negative infinity. Then we go to -9, the unity symbol, the -9 to 0, union with 0, 9, union with 9, infinity. That's what that would look like. Then for number 2, this is a radical. We can't have anything that's less than 0, so we need to set everything greater than or equal to 0. That's because if we have a negative in the radical, we'll get an imaginary number. So, looking at what's inside the radical, it would look like this. We can subtract 7 from both sides. We can then divide by -1, but when you divide by a negative, you have to flip the sign. And this leaves us with the interval notation of -infinity comma 7 bracket. So we can touch the 7. Moving on to number 5. We're looking at the functions f and g, and we have to find the indicated composition. And we have g of f of x. So when it says g of f of x, that means we put f into g. So this f of x function, which I'll highlight, is going to go into the g of x right there. So for every x in g of x, we plug in f of x. So 3, and then where it's the x, is now going to be 5x plus 4 plus 6. Expand this out. And this is what we're left with. Moving on to 2.7, we need to find the inverse of the one-on-one functions. And to do that, we're going to set the function to look like this, just equal to y. And then what we want to do is we want to switch the values. So what's y becomes x, and what's x becomes y. And you do this when you're looking for the inverse. That's why we flip it. And then we want to solve everything in terms of y. So we'll start out by taking the cube root of both sides. Which leaves us with the cube root of x equal to y plus 6. We can subtract 6 from both sides. And then once you have y by itself, you're just going to rewrite it with this inverse f of x sign and write it like that. For number 3, we have a similar problem. So again, we'll change that f of x to a y. Now we flip the y and the x and solve for y. To do that, we're going to need to square both sides. Then add 8 to both sides. Then we just rewrite it like this, because this is the inverse. Moving on to 2.8. It says we need to find the distance between the pair of points. So we're going to need something called the distance formula. It looks like this. And you're going to want to memorize that. So using that formula, we'll just take our points x1, y1, x2, y2, and we'll plug it in using the distance formula. And then we would just do the math by plugging into our calculator. We get to the square root of 20. We can then use like the radical tree method. See this split into 2 and 10. 10 splits into 2 and 5. And these match. So we can take the 2 out and leave the 5 in the radical. Now for number 2, find the midpoint of the line segment whose endpoints are given. So we'll have another formula called the midpoint formula. Which looks like that. And then we'll just take our points and plug it in. Then we just use our calculator. And that's what we get. For number 3, find the standard form of the equation of the circle given the center radius. So we have yet again another formula called the circle formula. Which is x minus h squared plus y minus k squared equals r squared. And this is h, this is k, and that 2 is r. And then we just plug in. And this becomes plus 7, because minus and negative is plus. And then all we need to do, we don't have to expand it out all the way. We do have to expand the right hand of the equation. And that becomes 4. Then for the last problem, number 6, complete the square, write the equation in the standard form, and give the center and circle radius. So when we start out one of these problems, we need to move the constants to the other side. So we'll subtract both sides by 85. When you do that, you'll have a negative 60. And then you're going to want to factor, let me think, what's the easiest way to explain this? You want to rearrange the x's together, so it looks like this, and the y's together, so it looks like this, and almost do like a little double factoring. So we'll call this sort of like the green side, and this is like the red side. And for the green side, we're just going to use the b over 2 squared, which you've seen before, and the b in this case is the 12, so it's 12 over 2 squared, and that's equal to 36. And since it's equal to 36, what we do is we're going to add that to both sides. So then we'd have but we still need to do the same thing for y, the red side. We'll just use b squared again. The b this time is at negative 14. Which is 49, so now we're going to add 49 to both sides. And then the right-hand side of the equation turns to 25. And then we want to look at all the y values plus the constant we added, and all the x values plus the constant we added. And we want to ask, what two numbers multiply to 36 and add to 12? And that's going to be 6. So we're left with x plus 6 squared. And then we need to add that to looking at the y values. Thing that multiplies to 49 and adds to negative 14, which would be negative 7. So we have y minus 7 squared, and that's all equal to the 25, which I wrote a little too far. So that gives us the equation we're looking for. And then the center would just be whatever makes the x and y part 0, so negative 6, positive 7. And the radius would be this 25 right here. We take the square root of it, which leaves us with 5. That's going to be all for this worksheet.